The muscle body is encased in which of the following? A. The perimesome. B. The episome. C. The endomesome. D. None of these. The answer is B. The episome. The muscle body is encased in a fibrous elastic sheath called the episome, epi meaning on or above and mys meaning muscle. It is composed of dense irregular connective tissue and is continuous with tendon fibers. The perimesome surrounds muscle fascicles, while the endomesome surrounds muscle fibers. Which of the following correctly describes an isometric muscle contraction? A. The amount of muscle tension increases without any change in the length of the muscle or the angle of the joint. B. This form of contraction can either be eccentric or concentric. C. There is a rapid burst of mechanical energy for a short powerful movement. D. The length of the muscle shortens and the angle of the joint changes during the contraction. The answer is A. The amount of muscle tension increases without any change in the length of the muscle or the angle of the joint. Isometric muscle contraction are those in which the tension in the muscle increases, but the muscle does not change length, nor does the angle of the joint change. An example would be attempting to push or lift an object that is too heavy to move. This is in contrast to isotonic contraction, in which muscle tension remains constant, but the muscle length and joint angle both change. During contraction, the A band of the sarcomere does which of the following? A. It lengthens. B. It thickens. C. It does not change. D. It shortens. The answer is C. It does not change. The A band in the sarcomere is created by the bipolar myosin filaments, joined at the M band. During contraction, the heads of the myosin filaments bind with the actin filament and pull it toward the M band at the center of the sarcomere. The myosin filaments do not themselves change length, and because of that the width of the A band does not change during contraction. In the sliding filament theory of muscle contraction, all but which of the following are functions of ATP? A. ATP does all of these things during muscle contraction. B. It moves the myosin head into a high-energy cocked position. C. It allows the myosin head to detach from the actin filament. D. It moves tropomyosin off of actin binding sites. The answer is D. It moves tropomyosin off of actin binding sites. According to the sliding filament theory of muscle contraction, ATP binds to the myosin head and is hydrolyzed to ADP and inorganic phosphate. The energy released during this change draws the myosin head back into a high-energy state, from which it is able to bind with actin and execute its power stroke, leading to muscle contraction. ADP and inorganic phosphate then are released from the myosin head and replaced by a new molecule of ATP, which allows the myosin head to detach from the actin binding site. All of the following features are unique to cardiac muscle cells except A. They form branching chains. B. They are linked together via intercalated discs. C. They are non-striated. D. There are gap junctions between cells. The answer is C. They are non-striated. Cardiac muscle cells are striated, branching cells that are linked by structures called intercalated discs. These discs are composed of gap junctions, which allow the free passage of electrical signaling between heart cells, and very strong attachment points called episomes.